Is Ethan Weiner's null test infallible? Sorry, I had to look down at that question to see it. It comes from Kai in Quebec, Canada. Hey Paul, I recently watched a video from Ethan Weiner on his new null tester and was immediately struck with a question because over the last year or so, I've been warming up to cables more and more, starting with a power cable, then headphone cables, and I noticed a clear difference with each of them, which Ethan is going to tell you it doesn't exist. So is the null test truly infallible? Well, let's talk about that. First off, even though Ethan and I don't agree on much, we do agree on one thing, and I respect him because he's doing his best to try and educate people and wants to share his knowledge, which he's got a lot of knowledge. And though we don't agree on a lot of stuff, Ethan, he's a good guy, and I think that's great. And like Steve Gutenberg, well, Steve and I agree on quite a bit. But anyway, fellow YouTubers. First off, it's not Ethan Weiner's null test. This null test has been done for years and years. First time I knew of it in public was Bob Carver in the very famous Stereophile challenge, where Carver took on the challenge of whether or not he could make a solid state amplifier sound as good as a Conrad Johnson Premier tube amplifier, something which he in fact did, and he used the null test to make that happen, and the Stereophile board could not tell the difference between the two, where formerly there was a huge difference between the two, even at the same gains. And Bob got in there, used the null test to bring the differences down. So the null test is we've used the null testing here on our scopes and things for years. So let me explain to you what the null test is. Null testing basically takes two electrical signals that are supposedly the same. But so let's imagine that we have a source here. We're going to put out something. We're going to put out a musical signal. And it doesn't have to be sine waves or anything tricky. It can be music. It can be anything. It can be noise. It could be whatever. And you take that source and you put it into two devices under test, or two wires, or two anythings, and you take their output and you make sure they're gain matched and as close as possible to each other, and you put them into an oscilloscope like this, and you do it to look at the differences between the two. For those of you that have power plants, you can go on your screen. All our power plants have, except for the P3. Anyway, most of our power plants have video screens on the front of them, and you can go in, and if you haven't done it, you should. You can go in and you can look at the incoming waveform of the power, and you can look at the outgoing waveform of the power, and then the very next screen is a null test. It shows what is the difference between those two. Right? And you can see all that stuff. That's the difference between incoming AC and outgoing AC. So that's basically a null test. You're just looking at the difference between two inputs. So what Ethan is doing, he's saying, all right, I've got a stock 12 gauge power cable, and I've got a fancy schmancy $300 power cable. And if I put power through the two and I run my null test, if you're hearing a difference between the two, then there should be an electrical difference to explain it. And that's what he's doing. And so, is it infallible? Well, yeah, sure it's infallible. Sure, it's fallible. Sorry, it's not infallible. It's very fallible in some respects. So first off, if there is an electrical difference between the two, then the null test will catch it every single time. It is infallible. Done. Said. where the fallibility comes in is when we're looking at two entities, like, well, let's take power cables, okay? Let's imagine that we have a fancy schmancy power cable and we plug it into our preamp and we hear that it sounds XYZ. Then we take the 12 gauge power cable, the stock one that came out of the box, and we listen to it. It sounds different. Ergo, there must be a difference. And indeed, there is. Does it mean that that difference has to show up on a null test? Well, no, if it's not electrical in the same way that you're running the test. So one of the things power cables are very good, well-designed power cables are good at is shielding, okay? So our cables are like triple shielded, right? And we have some, I don't know, somewhere on a YouTube video, we take a power cable and we show you with a, one of those testers that you put it over here and you hear it and then it's just gone. You take a stock power cable and it's producing all kinds of crap coming out of the wall. So we know that the noisiest electrical environment in our home is likely to be our stereo system. Everything else is pretty much in the wall, but here we have it coming out. We have digital equipment, we have high current power amplifiers, diodes switching, all this kind of crap going on, and these products are sensitive to EMI. This is just an example, right? So if we're to believe, and I do, that it's best to clean up the EMI before it gets into a piece of equipment, and that EMI is generally coming from the power lines in our homes that are acting as antennas to pick up all kinds of crap. And we can show that it actually does affect sensitive digital electronics, et cetera, et cetera. Anyway, I'm not going to make a case for that. But Ethan's null test won't show that. They'll look identical. So I guess bottom line is it doesn't look at everything. It is infallible for what it specifically looks at, which is electrical voltage differences. Now, one last caveat with that. Much also depends on how you terminate something, okay? So imagine if we're looking at a speaker cable and we want to see is if speaker cable A has any electrical differences between speaker cable B. Well, the only way to really tell that, of course, has to be playing a loudspeaker and the same loudspeaker at exactly the same levels, et cetera, because loudspeakers are inductive, they have all kinds of crazy stuff going on, and sometimes speaker cables react differently because it's the interaction between the loudspeaker and the cable that we're solving with different types of construction, et cetera. So yeah, I mean, it can be, but you got to be really careful because it isn't just so black and white as just take two cables, terminate them into a resistor, and see if there's any difference. That doesn't tell you squat. So, all right, long enough. Thanks for the question, and I'll talk to you tomorrow. Bye.